Okay, so another example is going to be about a mechanism that have platform, the BC, okay, and we have block on it. As the rotation of the link AB is going to be done due to the omega has been applied to it, the platform is going to remain horizontal. Anyway, uh, we have the mass of 10 kilogram box on the top of it that is going to have a friction between the platform and the box that prevents it from slipping. If the at this instant we show that the link AB is going to have the angular velocity of 2 radians per second, we need to find what will be the maximum angular acceleration going to be in that scenario. So the block is not going to be slipped. So this is a free body diagram and the kinetic diagram for that book and what we can see actually that this is center of gravity. I get to have the normal force and the friction force. You know that the friction force is equal to normal force multiplied by the coefficient of friction. In the kinetic diagram, we're going to have two forces. The first force is going to be the mass multiplied by the acceleration horizontally, and the other one is going to be the mass multiplied by the acceleration vertically. Now let's go back to the previous topic. When this part is rotate, we're going to have two accelerations, normal and tangential. That's the normal and that the tangential. And now we know how to calculate that by using the alpha and the omega. So let's go forward and see how we can solve this one. That's what's the solution given to you. The tangential is alpha multiplied by 1.5. The 1.5 is the length of the link BC. And the normal one is going to be equal to the omega squared multiplied by 1.5, and it's going to be 6 meters per second square. By doing the free body diagram and the kinetic diagram, we're going to find that the sigma of the forces normally vertically is going to be equal to the mass downward, the normal force upward on the free body diagram. On the kinetic diagram, we're going to have the mass multiplied by the acceleration normal, which is going to be the vertical one. And we can solve for that to find that the MB is going to be equal to 38.1 Newton. And we're going to do that for the horizontal. So the tangential force is going to be equal to the mass multiplied by the acceleration tangential or the horizontal acceleration. That's what we wrote the kinetic diagram. And what we have on that side is going to be the friction force, just the friction force. And we can find the value for the alpha. So let's start to do the analysis. Once again, this is a free body diagram. This is the kinetic diagram. Sorry, I put that on the side. It shouldn't be on the side, it should be on the middle. And we start to do calculation for both sides. Now, what we need to do is by knowing that link, the alpha is unknown, so I can say that the A tangential is going to be equal to the alpha multiplied by the length of 1.5. For the A normal, is going to be equal to the omega squared of 4 multiplied by 1.5. Okay, so that's it. It's going to be 6 meters per second square, and this is 1.5 alpha. So we know the coefficient of friction, we know the mass, we know the omega, and the unknown is going to be the alpha. Again, let's go back to this diagram. The vertical forces we have in this diagram is going to be W negative plus the N positive. And for the horizontal force is going to be the friction force, which is normal multiplied by the coefficient of friction. In the kinetic diagram, the horizontal is going to be the mass multiplied by the tangential acceleration, and vertical is going to be the mass multiplied by the normal acceleration. So we come to here, these are the equations we have. The moment is not going to be useful here, unless if you would like to know what's the location of the point A. So we continue with the calculation. The normal is going to be equal to the omega squared multiplied by the distance A to B, and this will make it 6 meters per second square. For the tangential, it's going to be equal to the alpha multiplied by the RAB, and this will be 1.5 times alpha. You're going to assume that positive, so the AGT must be positive in the defined frame we have here. So for the x-axis, for the y-axis, W downward, the N upward is going to be equal to the mass multiplied by the AGN. So that's what we have. Oh, this should be negative. Anyway, the W plus MP is equal to 10 multiplied by 6. This is multiplied, not x. Multiplied by 6. So we're going to solve and we're going to find the value for the MP is equal to negative 38.1. So here we're going to have 60, of course. Here we're going to have 96, sorry, 98.1. So we're going to take that to the other side. It's going to be negative. So we're going to have negative 98.1 minus 60 is going to be minus 38.1. Now, let's go to the next step. Okay, so it's going to be about the friction force. It's going to be equal to the mass multiplied by tangential acceleration. So now tangential acceleration is 1.5 multiplied by the alpha. So the coefficient of friction multiplied by the normal force is going to be equal to the friction force, and this will be equal to 10 multiplied by 1.5 alpha. So in this equation, just the alpha is unknown. So we can solve for that, and we will find that the value for it is going to be equal to the 1.02 radian per second square. Okay, so that's it for this example, and we're going to get another example very soon.